Hello. So in this video, we're going to be talking about geometric transformations. Specifically, we're going to talk about dilations. This is part one of a three-part series on dilations. There's quite a bit, and I wanted to chop it into smaller videos so you didn't get overwhelmed. So this is part one. We are specifically going to be focusing on dilating points. So part two, we're going to do dilating images, and part three will be determining the scale factor of dilation. In this video, though, we're going to talk about what is a dilation, how do we perform dilations, and how to tell if our image will be bigger or smaller, and then we'll work examples. So first of all, what is a dilation? Well, a dilation means that your shape is going to change size. It's going to get bigger or larger, bigger or smaller, shrink or enlarge. And so on all of our other geometric transformations, we talked about properties that are preserved. So the figure is going to retain its original shape and its original orientation, but in this case, the size is going to get either bigger or smaller. So if you've seen some of my other videos, you've met Mr. Spaceman. So Mr. Spaceman here. So, all right. As I move him closer to the camera, he looks like he's getting bigger. As I move him away, so original, move him away, he looks like he's getting smaller. That's technically what a dilation is. We are getting bigger or smaller. This, he's not physically moving, changing size. He's made of plastic, that's not possible, but as he's getting closer to the camera or further away, he looks like he's getting bigger or smaller. That's all a dilation is, bigger or smaller. And again, he kept his original shape, his original orientation, he just changed size from the viewpoint of the camera. He didn't actually change size. So when you're doing dilations, we're going to talk about this term called a scale factor. So dilations are all about distances. You're going to have some point of reference, and they're going to say, from this point of reference, dilate by this scale factor. So what you're going to do is you're going to find the distance from the point of reference to your point, and you're going to find that distance, and you're going to multiply that distance by the scale factor. Now, we can kind of sanity check ourselves. Is our image going to be bigger or smaller at the end by looking at what is our scale factor. If our scale factor is greater than 1, our image is going to be bigger. If our scale factor is between 0 and 1, our image is going to get smaller. We don't deal with negative scale factors. So let's go do some examples. All right, we have 2 points. We're going to dilate point A by a scale factor of 1/2 about point B. Scale factor of 1/2. What did we just say? We're going to get bigger or smaller? Smaller, or closer to point B in the case of just singular points. So we want to know what are the coordinates of the point A prime. So we talked about this is just finding distances. That's all we're doing is finding distances. So let's think about it. A is currently, so we're going to go from B to A. Some X amount and some Y amount. Some X amount and some Y amount. So our X amount, A is directly underneath B. We're not going anywhere in the X. 0. Our Y amount, though, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. A is negative 10 underneath B. So now, to get from B to A prime, so B to A prime, we're going to multiply both of these distances, the X and the Y, separately by 1/2. 1/2 X, 1/2 Y. 1/2 times 0. 0. 1/2 times 0 is 0. Anything times 0 is 0. Always remember that. 1/2 times negative 10, negative 5. Multiplying by 1/2 is the same thing as dividing by 2. Negative 10 divided by 2, negative 5. So now A prime, instead of being negative 10 underneath B, we're going to be half as close. So we're just going to be, again, 0 in the X, and just 1, 2, 3, 4, 5, right? 5, A prime. So we're going to be 5 below point B. So what are the new coordinates? Or what are the coordinates of A prime? Well, we are at 5, 1. Those are the coordinates of point A prime. We are half as close as we were before. So now let's try another one. All right, so let's look at this one. We want to dilate point A by a scale factor of 3 about point B. Okay, we need to find those distances. So from B to A, we need to figure out what is my x distance, what is my y distance. So my x is 1, 2, 3, but it's positive. So we're going to the right. So positive 3, 1, 1, 2, negative 2 in the y. So to get from B to A prime, our scale factor, we're going to multiply both of these distances by 3. So we're going to have 3x and 3y. So in our x direction, 3 times 3, we're going to be going positive 9. In our y direction, 3 times negative 2, we're going to be going negative 6. So let's graph that. So we're going to start at B. We're going to go 9 in the positive direction, 9 positive x, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to go down 6. 1, 2, 3, 4, 5, 6. A prime. Our coordinates, we end up at 7, negative 2 is our new A point. So this one, our scale factor was 3. That's greater than 1, which means that our image is going to get bigger. So A prime is going to be 3 times as far away from B as it currently is. All right, so like I said, this is part 1. This is just dilating points. Part 2, we're going to work on dilating images. Part 3, we're going to determine the scale factors. So go tune in to the next 2 parts. If you have any further questions, thank you for watching. For more math help, please subscribe to my YouTube channel. If you have a specific question for me, please visit my website and go to the contact page and submit your question via the submission form, and I'm happy to get back with you.